Thanks, Kate, and good afternoon. So let me just get this straight here. Excuse me. So I think we're all pretty aware that a lot of machine learning systems have resulted in predictions and recommendations that have been biased, discriminatory, and generally unfair. And what I'd like to talk about is something called Explainable AI, or XAI, which is really a series of techniques, procedures, and strategies that try to interrogate machine learning systems. And really, it's a way of trying to uncover what's really going on, and as a result, be able to understand why these systems are performing the way they are. So it relates to that issue around bias, but many other issues as well. And I think we're aware that the issue of what's going on with artificial intelligence is pretty profound. And Sophia Noble really nails it, I think, when she talks about it as a human rights issue, because it really does have that kind of importance and breadth, in fact, in terms of scope. So why are we worried about machine learning? What are some of the issues? I think, first of all, it's ubiquitous. It literally is everywhere nowadays. It's embedded in other systems. It's involved in so many processes we encounter. So it's there, and it's in virtually everything we can think of these days. So it's ubiquitous. It's also powerful. We know that this technology really makes a big difference. It's very good at recommending certain things. It's exceeding human performance in a number of specific areas. So it's well worth paying attention to. But it can be very opaque. We don't really know sometimes what's going on in those systems, why it's making the decisions, and how it's making the decisions. It's also invisible often. Machine learning can be embedded in other systems in such a way that we don't really know that there's algorithmic processing going on. We aren't aware that it's there, it's happening. But probably most important, we care about this because the decisions of these systems are consequential. They matter in your everyday life. So we really have to understand why they're doing what they're doing, why the outcomes are happening, and why they could be either beneficial or otherwise. So it seems to me, because of the power of this system, we are going to use these technologies. They're profound. So as this observation said, it's not that we're going to stop delegating cognitive tasks to machine learning systems, but we really have to understand what they're doing. And to not try to understand what they're doing is really an abrogation, I think, of perhaps even our professional responsibilities. So that's what we want to try and do with XAI, with the explainable AI. And when you think about it, at the core of XAI are really just two questions. What kind of explanation do we want as a person, as a user, as a designer? And how could artificial intelligence, how could a machine learning system actually deliver on that explanation? Now, the idea of an explanation from machine learning systems really got a bump recently when the GDPR, the General Data Protection Regulation of the EU, said that there ought to be a right to explanation for someone who had an algorithmic decision made about them. So this idea of a right to explanation really arose from this legislation and really has gone globally as various organizations and designers and companies are trying to figure out how they would actually be compliant. And we know, as we said earlier, that often these systems are very opaque. So there's a really interesting problem here in the sense that an explanation is required, but on the other hand, we don't really know how some of these systems work. I think the other thing to think about in terms of an explanation is who's the explanation for and what's the explanation about. And this chart really tries to show that there's maybe three communities who have an interest in an explanation, but for very different reasons. So developers might be interested because they're interested in functionality and, as a result, performance. And that's one set of explanations, one set of concerns. But users really think about it differently. They think about these things as applications, and really what they're interested in is, do I trust this system? Is it something I can rely on? And then you get regulators. And regulators are really in that governance space. And their interest here is really around policy and what kind of policy is necessary or available or required in certain cases. So when we look at a typical machine learning system, there are these sort of three major components. And quite often, in terms of the issues around bias, discrimination, and unfairness, we think about the data as a major source of that. And that's absolutely true. That's one area where this occurs. We also think that the algorithms themselves are contributing to that process as well. So the data and the algorithms kind of work together in terms of coming up with predictions that are unfair or biased. I would also tell you that even the computational environment, the compute environment, is part of that, because how much compute you have to work on those models, to look through that data, can actually determine whether you're coming up with a robust model or one which is maybe just okay, and maybe not then sufficient. So really those three components all have aspects to them which might be the source of some of that bias and some of that discrimination. And you'll see that XAI, the tools and techniques of XAI really do zero in on each and every one of those areas. But I think it's also important to think about machine learning systems in a much larger context, the political, social, and economic context in which these systems live and operate. And here maybe we're moving into that policy realm, that realm of regulation, but also perhaps ideology and corporate control, where some of these systems are really promulgated for reasons other than the interest of the user. They may be, well, the interest of the financial benefit of the corporation or other kinds of preferential treatment that regulations or even legislation might provide or enable in some way. So think about this as certainly as a technology issue, but also as a policy issue, which needs to be considered as well. So if you think about machine learning as that black box, that thing we can't really see in this opaque space where decisions are made, then XAI tends to look at three different strategies, if you will, to try and probe those systems and determine what's going on. One is proofs, one is validations, and the other is authorizations. So if we look at proofs, proofs really are things like causality models or logic models that can easily describe this action caused another action. And they're typically done in systems that are rule-based or use things like decision trees. So in a sense, classic AI, what we call GoFi, good old-fashioned AI, systems which in some ways are out of date, but actually are used still in a lot of systems right now because they are so transparent. They are easy to understand and easy to track. So lots of companies actually still use these systems for that very reason. Other systems, we also see though that there's been a real debate about the deficiencies of deep learning, and a lot of that original classic AI is actually coming back. So proofs are really important, but not really something we can apply to deep learning systems. Excuse me, I have allergies which are going to bother me here, excuse me. Okay, so validations are something very different. Validations really operate on the systems themselves, and often these are tools that designers can use, people who are building these models, building the systems around them. And they're looking at things like feature selection. How can we isolate certain aspects of a model, of an AI model, of a machine learning model, and see what kind of effect it has on the answer that it produces? And this way we can actually isolate where certain features, certain data elements, certain weightings actually cause the system to have one particular kind of answer or another. Often this is how we can detect where the bias is coming from, where the unfairness might be coming from, and actually adjust for that. We can also do things like replication studies to see whether if it's turned up in one particular machine learning model, it also turns up in another one or not. And maybe there's some differences in the way the data was applied or the model worked. And so there are a number of other possibilities there. One of the really interesting ones, which comes up a lot actually, is that maybe the one way to do the kind of interrogation we need in these very opaque systems is to have other AI systems do XAI. And so our answer to probing the systems is actually to develop oversight AI systems whose sole purpose is really to do that interrogation for us. So as I said, this is a sort of process where designers are looking at these kinds of tools as they build the models, as the training and the learning goes on with the data. The other area I mentioned was authorizations, and now we're kind of moving into the policy aspect of XAI. So now it's about establishing codes and standards perhaps, legislation, various kinds of regulations that might put barriers, guardrails around this sort of technology. So when people are building them, when they're testing them, when they're promulgating them, they actually respect the kinds of transparency, interpretability, and explainability that's necessary to really understand what's going on in these systems. One of my areas where I think there's a lot of work we could do is in the area of audit. Audit is a technique that we've used a lot in confidential systems like financial systems, for example, where we can preserve the confidentiality of the system, we can preserve the IP, something that's very important to a lot of machine learning designers, but we can also run standards against those things and determine whether those standards have been met and that these systems, while they may remain private, confidential, we can ensure that they're operating with the kind of transparency and rigor that we expect. So we can look at things like proofs, we can look at things like validations, and we can look at authorizations. But how would, say, the library community be involved in this? And I think there's kind of three possible areas where I think we can specifically make a difference. One certainly is in the area of algorithmic literacy. We simply can help people understand more what really goes on in an algorithmic decision-making process and how they can interrogate that themselves by asking questions, by asking for more information, and by really confronting the system in a more informed way. And we have a long way to go in helping our users, our user communities, really understand what's going on with algorithms. And I would encourage that, and we can talk a little bit more about some of the initiatives there. I think another important area is for us ourselves to become involved in machine learning development and participation in partnerships around machine learning development. We can be actively involved, and many more libraries are building their own systems or working cooperatively with other agencies to do that. But it really is a huge opportunity for us to ensure that the values that we have around the work that we do get reflected or embedded in these machine learning systems and start to really combat some of that bias and discrimination that we've been talking about. So really, XAI is a tool set, if you will, that we can use to really move that along and make these systems more effective and more reliable. And I think lastly, one of the things we really need to do is advocate on behalf of some of these regulations, legislations, and perspectives, codes and conducts and standards. And we can do that within our professional organizations, within government, within other nonprofit agencies, but really use our voice and the values that are behind that voice to make a difference in this space. And I can tell you that right now that the AI community, the machine learning community, is really looking for that kind of involvement. They recognize deficiencies here, and they recognize there are communities and other groups that really have something to tell them, something to help them with, and we certainly have a role to play there. So at the end of the day, I think what we're trying to avoid is what David Lankes called a new digital divide, where there are some people who can use algorithms and some people who are used by those algorithms. Thank you very much.
Thank you very much. Do you have any questions?
There's your chance, Sam.
Thanks, Michael. So it was interesting when you ended with Lankes's quote, which seems to imply that if we understand how these decisions are being made, then we can somehow defuse some of the political power. But from my perspective, that ignores the fact that it's not knowledge, but power itself that allows these things to take place. So from the perspective of explainable AI, it seems as though we're already assuming that non-human decision-making is a fait accompli. And so we're going to focus on having transparency around how those decisions are made after the fact. How much focus do you think we should still be placing on resisting non-human decision-making from the get-go?
Great question, thank you. Well, first of all, I mean, algorithmic decision-making is happening a lot, and many of those processes, I would say, are extremely valuable. We're discovering new things. We're working at a level we haven't been able to work at before in very complex environments. So I would argue that it is a good in itself. Having said that, the abuses are also huge and important to identify. So I think I would agree with you. I think what we need, and frankly, you've been doing some of that for us, is providing a critical lens for these sorts of processes. And that critical lens, after all, is something that we've done with information and information systems since day one, I think, and maybe more so now than ever before. So I think it absolutely may be one of our responsibilities to not merely be involved in this, but involved in a more critical way to have it evolve, have these decision-making systems, algorithmic decision-making systems, evolve in ways which are consistent with what we want. And I think you're absolutely right, that's not happening now. The development environment in ML is mostly around how more accurate can we get these systems to be. And they really do ignore a lot of the social, political, economic issues surrounding them. I have actually the wonderful opportunity to work with the Vector Institute in Toronto, one of the 3 AI institutes in Canada. And these people are brilliant, they're doing amazing work. But when I talk to them a little bit more about the context in which they work, it's not what they spend their time on. But I have to tell you, they are interested, they are concerned, and they're listening. So I think there really is an opportunity for us to do that. We can come back to the Power One question later, because I think that one's also huge.
Any final questions? Okay, thank you so much.